Good morning. I am R.Sabarish, Assistant Professor of Department of Mechanical Engineering, Bharat Institute of Higher Education and Research. The subject code is an U18PCME305. The subject name is in Fluid Mechanics and Machinery. Today we have to discuss about that application of Bernoulli's equation and some problems. So in the last video we have to discuss about the what are the applications will be use Bernoulli's equation. Okay, so in that parallel application, wherever you have to do it that any problem based on that force, incompressible fluid flow, which energy consider then involved. But we shall consider the application to the following measuring devices. There are three measuring devices will be the number one is a venturimeter, number two orifice meter, and number three pitot tube. Okay, so in this topic, today we have to discuss about the venturimeter topic. So the venturimeter is a measuring device to rate of flow of fluid flowing through a pipe. It consists of three parts will be the a short convergent nozzle part, and the second one is a throat, and the third one is a divergent part. So the convergent part means the largest diameter to smallest diameter. Then that will be called as a convergent. Then after that, the some diameter will be maintaining the same. That portion will be called as the throat. Then after that, throat to the end pipe that will be connected the expansion. Okay, the diameter will be gradually increasing. That will be called as a divergent part. So consider based on that venturimeter, it will be connected on the horizontal pipe. At that time, it will be connected with the some manometer, U-tube manometer setups will be the shown in the figure. So based on that letter, so we have to return that D1. So diameter of the pipe at section 1. Then P1, pressure at the section 1. Then V1, velocity of liquid flow at section 1. A1, area of the pipe at section 1. Okay, so the area means the circular section will be the, at the time we have to use that common formula, area is equal to pi by 4 d square. Okay, so the H means the difference of pressure on the liquid. So in that will be connected on the U-tube manometer. At the time in that manometer, the liquid will be flowing and light density means the high density fluid will be available on the manometer. So heavy density fluid will be passing on the pipe means light density of the fluid, it will be available on the inverter U-tube manometer. Okay, so like that arrangement that should be available. Similarly, for the section 2, D1, P1, D2, P2, V2 and A2 are the cross section values of the corresponding section 2. Okay, so now I have to apply that Bernoulli's equation at section 1 and 2. We know that Bernoulli's equation P1 by rho g plus V1 square divided by 2g plus Z, that is equal to 0. So here there are two sections we have to consider. P1 divided by rho g, the density of the liquid be same at start to end, and gravity also same. It will be connected on the horizontal pipe. So I have to return P1 divided by rho g plus V1 square divided by 2g plus Z1, that is equal to P2 divided by rho g plus V2 square divided by 2g plus Z2. Because the venturimeter will be fixed on the horizontal pipe, at the time you have to consider Z1 that is equal to Z2. Now I have to return the balance P1 divided by rho g plus V1 square divided by 2g, that is equal to P2 divided by rho g plus V2 square divided by 2g. Now I have to move it that pressure is on one side, P1 divided by rho g. Then so another side P2 divided by rho g will becomes on this side means the plus will be converted into minus P2 divided by rho g, that is equal to V2 square divided by 2g minus V1 square divided by 2g. Now I have to return P1 minus P2. I have taken as a common is an rho g. P1 minus P2 divided by rho g plus V2 square divided by 2g minus V1 square divided by 2g. Okay, so already we know about the difference of pressure level at the time that will be returned. P1 minus P2 that will be considered as a potential head. P1 minus P2 divided by rho g, that is equal to H. Okay, so I have to substitute that instead of that P1 minus P2 divided by rho g I have to return as an H for the section 1 and 2. Okay, so I have to return H is equal to V2 square divided by 2G minus V1 square divided by 2G. Okay, now I have to calculate that what is the value for V1 and what is the value for V2. Now I have to apply the continuity equation at section 1 and section 2. So Q1 that is equal to Q2, Q means the area into velocity, A1 into V1 that is equal to A2 into V2. So we have to enter V1 that is equal to A2 into V2 divided by V1. So now I have to substitute that V1 value in that above equation in H. So now I have to return H is equal to V2 square divided by 2G minus A2 V2 divided by A1 divided by 2G. We have to mention is that square on the top portions only. Then next thing we have to take it as a common. Is then V2 square divided by 2G that will be common on both sides. So H is equal to V2 square divided by 2G into next one we have to open the bracket 1 minus A2 divided by A1. Okay. So like that I have to enter. So A2 square divided by A1 square. Now I have to do it the cross multiplication inside the bracket only. H is equal to V2 square divided by 2G A1 square minus A2 square divided by A1. Okay. So now I have to do it the cross multiplication because I have to find out the V2 value. So V2 square that is equal to divided by the GH will be comes on this side means 2GH A1 square divided by A1 square minus A2 square. Okay, so I have to return. Here I have to find out that V2 value. So the square will be moving on the other side means the square root. So V2 is equal to root of 2GH into root of A1 square divided by A1 square minus A2 square. So the A1 square I will be taking to the root. So finally I get it at A1. So V2 is equal to A1 divided by root of A1 square minus A2 square into root of 2GH. Now I have to substitute that value in continuity equation. So Q is equal to A2 into V2. Now I have to return Q is equal to A2 into A1 divided by root of A1 square minus A2 square into root 2GH. So I have to return here. Next step, I have to return directly. Q is equal to A1 into A2 divided by root of A1 square minus A2 square into root of 2GH. Now I have to change that one. Q is equal to root of 2GH A1 into A2 divided by root of A1 square minus A2 square. So here we find out the theoretical actual value. So we have to calculate the theoretical value at the time the equation based on the under the condition is called the theoretical discharge. Actual discharge will be less than 1 at the time you have to multiply with the coefficient of discharge. So Q actual that is equal to C suffix D that means the coefficient of discharge A1 into A2 divided by root of A1 square minus A2 square into root of 2GH. So that should be written here. And the coefficient of discharge value is any time is less than 1 only. It's having a 4 conditions to be there, man. Case 1, case 2, case 3 and case 4. Okay. So all the conditions are different. So first we have to discuss about the case 1. Let the differential manometer contains a liquid which is heavier than the flowing through the pipe. Okay, which one will be flowing? That will be heavier than that part. Okay, then case 2. In the differential manometer contains a liquid which is lighter than the liquid flowing through the pipe. Then third question, inclined venturimeter, which differential U-tube manometer, it is considered a liquid which is heavier than the liquid flowing through the pipe. And case 4, if the inclined venturimeter with the differential U-tube manometer, it is contains a liquid which is lighter than the liquid flowing through the pipe. So based on the fourth condition, the separate formulas will be available for that point. First, we have to discuss about the case 1. let the differential manometer contains a liquid which is heavier than the liquid flowing through the pipe. So H is equal to X into S of H, S0, SO minus 1. So SH means the heaviest liquid. Specific gravity, S means the specific gravity of heavier liquid. Then S naught means specific gravity of the liquid flowing through the pipe. Then X means the difference of heavier liquid column in U-tube manometer. Similarly for the case 2, if the differential manometer contains a liquid which is lighter than the liquid flowing through the pipe. So H is equal to X into 1 minus SL SO. SL means lighter liquid, specific gravity of lighter liquid in U-tube manometer. Then SO means specific gravity of the liquid flowing through the pipe. X is equal to difference of lighter liquid column in U-tube manometer. Then case 3 inclined manometer. Benchrometer with differential U-tube manometer. It is contained a liquid which is heavier than the light flowing through the pipe. So the first formula, the case 1 formula, we use it on here also. H is equal to X into SH divided by S naught minus 1. SH means specific gravity of heavier liquid. SO means specific gravity of the liquid flowing on the pipe. Then X means that they are differential manometer distance on in U-tube manometer. Then fourth one, inclined benchrometer with differential U-tube manometer. It is considered a liquid with lighter than the liquid flowing through pipe. So H is equal to X into 1 minus SL divided by SO. SL means already we discussed. SL means the specific gravity of lighter liquid. Then S naught means specific gravity of the liquid flowing on the pipe, and X means the difference of manometer on the liquid column in U-tube. Then based on it we have to discuss the problem. So first you have to write the question. Horizontal benchrometer with inlet and throat diameter 30 centimeter and 15 centimeter respectively is used to measure the flow of water. The reading of the diameter is a differential manometer connected to the inlet and the throat is 20 centimeter of mercury. Determine the rate of flow. Take coefficient of discharge is equal to 0.98. So first we have to write the given data, or you have to draw the diagram. Okay, so first I have to choose it for the given data. So diameter of the pipe in inlet is an D1 is equal to 30 centimeter, and area of that pipe pi by 4 d square. Finally we get that one value 706.85 centimeter square. So I have to return the diameter of the throat. D2 is equal to 15 centimeter. Then area of the throat A2 is equal to 176.7 centimeter square. Then H value will be given. So the coefficient of discharge is then 0.98. So the next step I have to do it for the H value. Okay, difference of mercury level. So H is equal to lightest liquid will be moving on the pipe, heaviest liquid will be available on the manometer. So the manometer means is that mercury. Okay, so that will be mentioned on here, 20 centimeter of mercury. So at that time I have to use it that for H is equal to X is equal to 20 centimeter of mercury. H is equal to X into S of H divided by S naught minus 1. That will be considered on the case 1 because it's an benchrometer, it's not in the inclined benchrometer. So SH means specific gravity of the heavier liquid, then SO means specific gravity of the flowing liquid. So specific gravity of the heavier liquid means here we have to get heavy liquid is an mercury. So specific gravity of the mercury means is then 13.6. Okay, so everyone know about that specific gravity of that mercury, density of the mercury is then 13,600. But here we have to consider is then specific gravity. So specific gravity that is equal to density of the liquid divided by the density of the liquid. So density of the liquid means is then 13,600. divided by, normally we have to consider the standard liquid means is an 1000. Example, water. So the standard liquid is considered as an water. So 13,600 divided by 1000. At the time it will be returned 13.6. Similarly, we have to calculate the density of the liquid in the pipe. So the water will be flowing. So the water density of the water is an 1000. Okay. So 1000 divided by 1000, I have to return S naught is an 1. Okay. So minus 1. I have to substitute all the values. So H is equal to 20 into 13.6 divided by 1 minus 1. So at the time H is equal to 20 into 12.6. Okay, so finally we get that H value. H is equal to 252 centimeter of water. Okay, now next step I have to apply the continuity equation. Discharge of the Venturi meter. So Q is equal to root of 2GH into A1 into A2 divided by root of A1 square minus A2 square. So here I know that all the values. So root of 2 into gravity 9.81 into H 252 into A1, we find out that 706 something, then A2 176 something like that. Then coefficient of discharge is at 0.98. Okay, so like that we have to substitute all the values. Finally you are getting your answer. Q is equal to 86067593.36 divided root of 499,636.9 minus 31,222.9. Again I have to take it as a root. So 86067593.36 divided by 684.4. Okay, then we get next one, we have to find out the some value. That value is in centimeter cube per second. 125,756 centimeter cube per second. In that question we have to convert into liters. So at the time Q is equal to 125.756 liter per second. Already we know that 1 meter cube, that is equal to 1000 liter. Here it will be given on the centimeter. So 10 power 3, that's divided by 1000. That's why it will be written Q is equal to 125.756 liter per second. Okay, next one we have to do it another one problem. An oil of specific gravity 0.8 is flowing through a Venturi meter having inlet diameter 20 centimeter and the throat diameter 10 centimeter. The oil mercury differential manometer shows a reading of 25 centimeter. Calculate the discharge of oil through the horizontal Venturi meter. You have to consider coefficient of discharge, that is equal to 0.98. Next, I have to write the given data. Specific gravity of oil, yes, go, because that is the lightest liquid, 0.8. Then next one, specific gravity of mercury is the heaviest liquid, that is equal to 13.6. So next step, you have to write the diameter of the inlet D1, that is equal to 25 centimeter. Then D2 is equal to 10 centimeter. Similarly, we have to find out that A1 and A2, and X will be given reading on the differential manometer is an 25 centimeter, like that. So A1 is equal to pi by 4 D square. Finally, we get that 314.16 centimeter square. Then second one, D2 is a 10 centimeter. A2 is equal to pi by 4 D square. Finally, we get that 78.54 centimeter square. Next step, the same procedure. The H is equal to, coefficient of discharge also will be given 0.98. Then next step, we have to find out the H value, difference of pressure head. H is equal to X into SH divided by S now O minus 1. Okay, so X value is an 25, inside the bracket 13.6 divided by 1 minus 1. So finally we get that 25 into 12.6, we are getting some value. That one is an 400 centimeter of oil. Okay, so we find out the H value. Next step, you have to find out the rate of flow of your Venturi meter. So Q is equal to CD into root of 2 GH A1 into A2 divided by root of A1 square minus A2 square. I have to substitute all the values. So Q is equal to CD 0.98, A1 304 something, then A2 78.54, then divided by root of 314.16 square minus 78.54 square into 2 into gravity 981 into H is an 400 centimeter. So normally we know that 9.81 in the gravity is a 9.81 that value, but here we have to convert all the values in centimeter, so that's why we have to return is a 981 centimeter. So Q is equal to, we have to get it one value 214,213.75.68 divided by root of, we have to simplify it again, we have to return 214,213.7.68 divided by 304 centimeter cube per second. Finally we get that Q is equal to 70465 centimeter cube per second. You have to convert into liter, 70.465 liters per second. Then next one, momentum equation. So based on the law of conservation of momentum, or on that momentum infer, we state that the net force acting on a fluid mass is equal to the change of momentum of fluid flow per unit time in the direction. The force acting on the fluid mass m is given the Newton's second law. So F is equal to mass into acceleration, capital M into A. So A is an acceleration acting on the same direction as force F. So that will be returned A is equal to dV divided by dt. Now I have to substitute that A value in the Newton's second law. At the time I have to return F is equal to m into dV divided by dt. Now I have to return F is equal to m, sorry, dmv divided by dt. I have to do it the cross multiplication, F into dt, that is equal to d into mv. That will be considered as a momentum principle. Okay, F into dt, that is equal to d into mv. So which is known as the impulse momentum equation, that states that the impulse of force F acting on a fluid of force m in the short interval of time dt is equal to the change of momentum dme in the direction of